Okay, we're going to start off by reviewing sections 5.1 and 5.2. Evaluate the integrals. Our first one is going to be 9t squared minus 4t plus 3 dt. Okay, by our rules, we can break this apart, and when we find the antiderivative of 9t squared, for this first one, we'll just have 9t to the m plus 1, or on your notes, r plus 1. All right. When we do this one, we get what? Negative 4 t squared divided by 2. And then plus, let me change color again, and then we get plus 3t. And we always need to remember what? Plus a constant. Good. So now let's just go ahead and simplify this. And this is just going to simplify to 3t to the third minus 2t squared plus 3t plus c. Now, if you're not sure, I'll go ahead and put, some of you have the copy in front of you, but if it's the integral of x to the r dx, then we'll have x to the r plus 1 over r plus 1 plus a constant. So that's the rule that we just used. All right, number 2. Yeah, so on this one, if we have options to be able to use algebra, we'll try to use algebra first and then our integration rules. So let's go ahead and FOIL this out and simplify. Okay, now once we simplified it algebraically, we're ready to find the antiderivative. So we start with that first term, 6x cubed, which is just going to be x to the third divided by 3 minus to the m plus 1. So there's a known 1 right there. So 1 plus 1 is 2, and then minus 5x plus a constant. So when we simplify this, we would get 2x to the third. We'll have 13 halves out front. X squared minus 5x plus a constant. Okay, with number 3, we're going to rewrite this with an exponent. So now we're ready to integrate. So I'll take the antiderivative. So 1 half plus 1, which would be 2 halves, is just going to be to the 3 halves. Divide by 3 halves, but remember when we work this out, it basically gives us the reciprocal out front. Plus, the antiderivative of the cosine of t is the sine of t, if you look at your formula sheet, if you're not, haven't memorized that just yet. Oops, plus a constant. And there's not really anything else I can simplify any further there, so this is where we stop. Okay, just like when we have the opportunity to be able to simplify algebraically, we'd like to use trig identities to be able to simplify if possible. So we want to rewrite this as tan x, and then 1 over the cosine is secant x. Alright, so then that's going to be secant x plus a constant. Okay, on this particular one, we want to bring the negative 1/5 out front, and then we'll just have the sine of u du. This negative 1/5, just we bring that down, and then what is the antiderivative of the sine of u? Right, negative cosine of u plus a constant, so then a negative times a negative, this is just going to simplify to 1/5 cosine of u plus c. Okay, we start with number 6, and we want to rewrite this using an exponent. Now this is the case when we use u substitution. We can see that this is more complex, and we would allow that to be our u. So if we come off to the side and we say u is going to be 3x minus 2, okay, what is the derivative of u? 3, and then don't forget dx, right? So 3 dx. Now we want to rewrite our integral so that it's u to the 1/2 du, and we want to make sure that everything's accounted for. So this is u to the 1/2, so if u is this to the 1/2 power, that's fine. And then we need just dx. This 3 is extra. Okay, we want to account for that and not have that extra piece of information. So what do we do with that? We will pull a 1/3 out front because the 1/3 and the 3 will reduce to just 1. And we rewrite this as u to the 1/2 du. Now we are ready to go ahead and find the antiderivative of that, which would be, I'm going to come over here. My 1/3 is just the 1/3 out front. And then the antiderivative of u to the 1/2 is u to the 1/2 plus 1, which is 3/2, divide by 3/2, which will give us this. And then we have plus a constant. Now let's go ahead and simplify that a little bit further, and we multiply that out, and that would give us 2/9 u to the 3/2 plus a constant. Make sure this entire fraction is an exponent. It's hard to see that there. Okay. Now, remember when we have u substitution, we can also take one more step and plug u back in. So it would be 2/9 parenthesis 3x minus 2 raised to the 3/2 power plus a constant. And we did that a lot in the lesson. All right, let's look at the next one. Okay, our first step is we want to rewrite this radical using exponents. Now, we want to be able to, if we're using u substitution, we're going to choose this one to be u. And we talked about this previously, the best way to select u, and sometimes it's trial and error. If it doesn't work out for you, then try the other term. But in this case, it's usually the one that's raised to the exponent. So if we say, let's let u be v cubed minus 1, what would be the derivative of that? 3v squared dv. Okay. All right. So let's rewrite this. U to the 1/2 power du. Now, when I look at this, when I rewrite it, I want to make sure that everything's accounted for. So I have u to the 1/2 power. That covers this. So what's left over is v squared dv. Well, I have v squared dv, but what's extra? A 3 again, which is similar to the last one. So how do we account for that? 1/3, we pull out a 1/3, and then when we rewrite it, we'll have this. Now we're ready to take the antiderivative, so my 1/3 is just 1/3, and this ends up being very similar to the last one, unintentionally, but u to the 3/2 divide by 3/2, which would give us this, plus a constant, and once again it simplifies to 2/9 u to the 3/2, but this time I'll plug my u back in so you can see it. Well, I'll do it in a second step. U to the 3/2 plus c, which that is also the same if I substitute my u back in, just so you see it in one. Which we've been leaving our answer in this format in the past ones, but that's just for you to see it. So when we have the cosine of something more here, that kind of denotes u substitution there. So we're going to let u equal 4x minus 3. What's the derivative of u? Just 4 dx. Good. Now we would rewrite this as the cosine of u du, and let's make sure everything's accounted for. The cosine of u is fine. We have dx. What's extra? The 4, so let's accommodate for that. So we'll have 1/4 cosine of u du. Now we're ready to take the antiderivative, and the 1/4 is just out front. What is the derivative of the cosine? Sine of u plus a constant. Okay, once again, our first step is going to be a rewrite step. So rewrite this with an exponent. Okay, good. And we're going to choose our u to be 3x squared minus 7. So what's the derivative of u? 6x dx. Good. Now, when I rewrite this, I'm going to have u to the 1/2 du. Now, let's check to make sure everything's accounted for. So u to the 1/2 would be all of this. Du is going to be 6x dx. I need the 6x to be what? 9x. So in my mind, this one I'm going to have to solve for it. So I'm going to say 6. I need that 6 to be 9. So 6 times what would be 9? 6 times what number would give me a 9 there? I'll just let that be x. So I'll say 6 times what number can make that a 9? Because I need it to be a 9. So if I divide both sides by 6, right? Divide by 6. X must be 3/2. Right? So if I pull the 3/2 out front, then I have u to the 1/2 du. So that one took a little bit of extra work. Now the antiderivative of this is similar to what we've been doing. So that's going to be bring your 3/2 down. That's out front. Now the antiderivative is going to be u to the 3/2. Divide by 3/2, which would give us this. Now what happens to those? Yeah, they end up canceling. And we're just going to be left with u to the 3/2 plus c. Which you could always take this next step and replace u back with 3x squared minus 7. Okay, and our last one, we're going to come down here and let this be our u because it's u squared. So let's let u equal to 1 minus sine of x. So that means our derivative is just going to be, the derivative of the negative sign is going to be negative cosine of x dx. Because the derivative of just sine is cosine, this negative is just brought down. Alright, now when we rewrite this, it's going to be, if I have 1 over u squared du, let's check out and see that this is equivalent. 1 over u squared gives me this u squared, and then the du is the cosine of x, but what's extra? A negative. Good, so we're going to account for the negative, and then I'm going to, what's the easiest way to rewrite that? Bring it up to in the numerator and write it as a -2. Now we're going to take the antiderivative, so I'll bring my negative down, and then that's going to be u to the -2 plus 1 is -1 divided by -1. So that's just going to be simplified to u to the -1 plus c.